Okay, we will, I think Vaughn wanted me to go back and go back a couple slides. So hopefully you're all here. Vaughn, you asked me to go back and talk about this slide again. I think you might have gotten disconnected or something. So again, concrete has great compressive strength, right? Compressive is squeezing together, but poor tensile strength. Tensile strength is stretching apart. So to improve the tensile strength, the weak tensile strength of concrete, we reinforce it with steel. Steel has excellent tensile strength, right? Think about the Golden Gate Bridge or the Brooklyn Bridge, right? You have those steel cables that are supporting the bridge deck, right? Those steel cables are in tension. So steel has great tensile strength. Putting concrete and steel together with reinforcement produces a much better product, right? Those, we'll see in a couple of slides here, the deformations or those ridges on the steel bars, on the rebars, improve the bonding between the rebar and the concrete. And again, those rebars are set in place along with the formwork before we pour the concrete. Right, here's our types of forces. Again, compression is squeezing together. Tension is stretching apart. And shear is a sideways force. So again, we're adding reinforcement to concrete to improve its tensile strength and its shear strength. So here's a picture of reinforcement in place while concrete is being poured. And you see a couple different types of rebar. Right, that's all put in place along with the formwork prior to the concrete being poured. Right, this I'm on page 111 in the textbook if you're following along. So a picture of reinforcing steel or rebar, commonly called a rebar, right? Bar number multiplied by 1/8 of an inch equals the bar size, right? So number 3 rebar is 3/8 of an inch. I have lots of pieces of number 3 rebar sitting around my house. They probably fell off the back of a truck at a job site someplace, but I use the number. I pound the number 3 rebar into my garden during the summertime to help hold my tomato cages up. That's just about the right strength to hold my tomatoes up. It comes in handy. Yes, Ayana.
Yes, good night. Is the 3/8 of an inch the smallest?
Yes, that is correct. Yep. Again, when we start in the coming weeks to look around at the drawings, we'll look and see how the drawings handle rebar sizing. But again, the architect or the engineer will add rebar into the steel to give it the desired properties. And the architect or the engineer will, select the size of the rebar and its spacing, along with the thickness of the concrete and the mixed properties of the concrete to give the strength desired. So again, all different things that the architect or the engineer, the designer can work with to produce the desired results. Right, those of you who live in Oak Park, and hopefully others of you will be familiar with this particular structure here. This is an early photograph of Unity Temple, right? This is a famous Frank Lloyd Wright building in downtown Oak Park. Opened in 1907, a very early example of a poured concrete building. You know, one of the first concrete buildings built in the United States. Actually underwent a fairly major restoration a few years back. You know, with 100+ years of Chicago winters and freezing and thawing, a lot of that concrete had started to deteriorate. So, you know, the bad concrete got chipped away and put back in place. And the result is the building looks almost as good as new. Not perfect, but it looks pretty darn good. So, if you happen to be driving around in downtown Oak Park, you can take a look. Hopefully, when this COVID thing is over, I'll be able to go back inside. So it's actually I'm a member here. It's a Unitarian Universalist congregation, so you can always come to church on Sunday morning if you want to get into the building for free. But anyways, this is an early example of a concrete building, concrete structure. Sorry for the digression here. Again, in a set of drawings, you'll see the use of concrete and aggregates as well as reinforcement, right? Let me turn my pointer here. Right, so here's a poured concrete footing with a piece of rebar in it. And then these concrete block, or CMU, as we'll see in a few slides, are set on top of there, and the core of that block is grouted with additional rebar. And then again, we have another piece of rebar set in grout where the sill is placed. So again, and here's some aggregate that backfills around the drain tile. Again, we in the coming weeks we'll be able to read and interpret this sort of thing on drawings. So again, you'll see these various components that we just talked about. Right, again, here's another example of a, this happens to be on, oh, maybe it's not. I thought it was in the textbook. Francis must have grabbed this from someplace else. Like, excuse me, again, examples of, sorry, what concrete will look like. Concrete plus rebars will look like in a drawing section. Welded wire fabric, again, another steel material that's used to provide reinforcement to concrete. Prefabricated material used to reinforce concrete slabs and floors. Right, wire mesh welded together, designated by numbers. This information is on page 113 of the textbook of Unit 7 in the textbook. Right, wire spacing and wire sizing. And again, here's the table in the textbook, talks about common sizes of welded wire fabric. Right, here's welded wire mesh. Again, you can see in this case, somebody has fabricated or put together rebar in two different directions and welded it together. And again, reinforcement forms go along with reinforcement. So again, you're typically going to, for a concrete structure, depending on what it is, there'll be formwork, there'll be some type of reinforcement of some of the types we just talked about, rebar or welded wire mesh. And once those two things are done, then voila, the concrete gets poured in. In one form or another. A few days later, the forms are taken off or stricken, and construction continues. So again, if you look around, you can probably see this sort of thing happening lots and lots of places. Okay, moving on to Division 4. Again, I'm on page 112 in the textbook if you're reading along. Right, Division 4 is masonry. So these are building units or building blocks, right? Just like your Lego blocks or Duplo blocks that you might have had when you were a kid. Right, some of the common types of masonry or masonry units are brick, concrete block, or CMU, concrete masonry unit, clay tile, and stone, right? All masonry materials that are used in construction. Lots of different types of brick. Obviously, the most common ones in our brick city would be a face brick and common brick. Right? We have pavers and glazed brick and fire brick and adobe. Right? Lots of different kinds of brick. Right? Adobe is a indigenous or site-built material. Right? We talk about this in my sustainability class, ARC 110, locally sourced materials. Right? Adobe is an example of a locally sourced material. Right? You can dig the components out of the ground on the building site and make sun-dried bricks, right, and construct a dwelling of it. Common in many parts of the world. Right, here is face brick, right, so this would be typical for, right, in a Chicago bungalow or a 2-flat or a 3-flat, right, the front of the building is face brick. The elevation that's facing the street. Sides in the back are common brick. Right? We have a whole city built this way. Right? We live in a brick city. Bricks come in a number of sizes and shapes. Sorry, a little bit hard to see that up to see that, right? But you see a standard brick size of 8 by 3/4 by 2 1/4, right? And brick positions. It's also shown in figure 712 on page 115, right? The stretcher, header, sailor, soldier, right? The different positions that bricks can be placed in laying up a wall. So again, the mason who is building the brick wall may vary the position of the brick to either produce visual effects or to add strength to the wall, right? Especially if the wall is more than one brick in thickness, right? Each set of bricks is a wythe. So in a single wythe wall, right, we have no reason to tie the wythes together. But as we get into multiple wythes or multiple thicknesses of brick, right, then we'll turn some of the bricks, essentially rotate the bricks 90 degrees from, the header rotating 90 degrees from the stretcher to tie those wythes of brick together.
What word were you using that started with a W? Can you spell that?
Yes, it is wythe, W-Y-T-H-E, and let me see if I can find it in the book. Top of page 116, I also, brick walls can be laid up in a single wythe wall, W-Y-T-H-E.
Thank you.
Oh, you're welcome. Good question. I don't know which came first, width or wythe, but think about wythe. Think about wythe and width together, right? Because wythe is, in essence, the thickness of the wall, or width of the wall. Brick bonds are different patterns. Bonds are bricklaying patterns, right? The bonds are used to provide strength to the wall and or improve its appearance. So again, the next time you're walking around looking at a 2-flat or a 3-flat, take a look carefully at the brick wall and see if you can pick out the bond. Right, you're quite likely to find this common bond here, right? Every 6th or 7th row, that stretcher is turned sideways, right? So these are stretchers, these are headers, right? You turn the brick sideways, and this is used to tie the wythes together, right? So bonds are bricklaying patterns. Up here we are, single wythe. I should have anticipated that was coming, right? So wythe would be a single width of brick. In this case, we're using both brick and block together. And here we've turned that, here's our stretchers, here we've turned that brick sideways, or a header, to tie these two materials together. In this case, we're using steel ties. This would be an example of a brick veneer. So again, this is a single layer, a single wythe of brick. It's on the outside of a wood frame structure. So again, if you're shopping for a house and you see a nice brick house, make sure it's solid brick, or rather than brick veneer, or at least know what it is that you're buying.
So, really quick, you talked about the bungalow. So are the old like the Chicago bungalow, that style of house, is that like the single wythe, or is it difficult to know?
Yeah, it's probably 2 or perhaps 3, depending on the height. Again, a typical bungalow or a typical Chicago 2-flat or 3-flat is not wood framed. It's typically going to be probably 2 widths of brick, and then it has lath and plaster on the inside. That's going to be a typical Chicago construction. But if you're curious enough, you could take a tape measure and go to a window opening and see if you can figure out the width of, or the depth of the masonry, by measuring the
Okay,
width of the
thank you.
wall of the window opening. Does that make sense?
Yeah, it does. It does. I just didn't I knew that they were brick, but I guess I was thinking that it was maybe a veneer, but it's not.
Well, you might have to poke around. Again, if it's your house or, someone in your family, now that you know a little more, you can poke around and try to figure out how things are put together, right? I'm always curious, right? I like to figure out how things are built, how they're put together. So you can do the same thing. Try to determine, how a 2-flat or a bungalow or a 3-flat, how it's put together, right? Where is the face brick? Where is the common brick? What bond is used in both, in either area? Did they do something fancy with the face brick to jazz up the front of the house, right?
Thank you.
Oh, you're welcome. Yeah, I mean, again, I live in South Oak Park, so we're right near Berwyn. Berwyn has got lots and lots of brick bungalows with, hundreds of different variations on the same theme. So I find it intriguing, the way that you can, as an architect or as a builder, you can take fairly common materials and put them together in dozens of ways.
Would the gray stone buildings be considered as from gravel, or would that be like broken down from boulders or something?
Yeah, good question. Yeah, again, in Chicago, there's probably lots of gray stone, especially 2-flats. So that stone would have been, quarried and broken up into a particular size. So I'm guessing what's happening is that that stone may be one of the widths or one of the courses of brick on the front of the structure. Yeah, good question. Yeah, lots of gray stone 2-flats and 3-flats in Chicago. I think they're great looking buildings. I will see if I can dig up some details for you, Jaquan, as to exactly how thick that stone is and whether that stone by itself is the entire structural wall or whether the stone is backed up by brick. I'm going to guess it's stone and brick put together, because stone is going to be a more expensive material than brick. So if I was the builder, I would use a single layer of stone to make the building look good, but then I'd sneak brick there behind it, so I'm not killing my budget with all that stone.
Oh, so the stone is way more than the brick.
Not that it weighs more, it's going to be more costly, a more costly material. Again, rarely do you see if you have a gray stone, the stone is really just on the front of the building. It's there for ornamental purposes. So I'm going to guess that stone, relatively speaking, was more expensive than the brick. You know, if the stone was cheap, they would have carried the stone all the way around all four sides of the structure rather than just putting it on the front. But I'm just guessing. I'll see if I can find out more about gray stone, Jaquan.
Thank you.
Oh, you're very welcome. Right, so we talked about bricks as being a standard unit of masonry. The other standard unit of masonry is a concrete block. Right, here's, again, concrete block plus mortar gives us a finished size, gives us a standard finished size. Concrete block is going to be very, very common in commercial construction. Right, here's a concrete block, sometimes called a cinder block or a split-faced block. Right, again, this split-faced block might be the way that we mimic the look of gray stone. And again, you see the cores in the block can be filled or grouted, or combination of rebar and grout. We saw that in those details a couple slides ago.
Is that a cheap, quick way to build up a house?
Cheap, yes. Again, it's uncommon to find concrete block in residential construction. It's very common to find concrete block in commercial construction. I can't think of, I'm struggling to think of houses in my area, or houses that I've seen that are concrete block construction.
Yeah, I'm wondering if, and then it would be like some kind of veneer or something in front of it to, like you said, hide the CMU. But I don't know. I was just wondering because it seems like all you would do is just kind of, you obviously need to stack those and apply the mortar and stuff, but you don't have to. You don't necessarily have to do some of the other things that you might have to do if you're building a house out of a different material.
Yeah, I think that wood is by far the more common material, or most common material that we build, houses from, and even probably low-rise, townhomes and low-rise construction is probably still built out of wood. You might have concrete block inside that someplace if you have a multi-family dwelling or multi-unit building and you want to provide fire resistance between units. That might be done with concrete block. But I don't know. I'll have to see if I can find some data that shows, houses made of wood versus houses made of brick or block. Right? We know what the three little pigs favored, but I think we have a lot of stuff made out of wood. Good questions. Again, concrete blocks are going to be in a variety of shapes and sizes. And those standard sizes laid up with a standard mortar joint produces predictable dimensions. And we can put color on the block when this rounded corner is called a bull nose. Right, so we can glaze the block. You might see this glazed concrete block in a you know, let's say in a restroom in a public building, right? The restroom might be, you know, glazed concrete block. That would be a good application for it. Okay, so we have bricks, we have concrete blocks, and we have stone. Right? Stone, again, are common building materials. Probably stone going to be less common these days than brick or concrete block. Different terminology that's used to describe the way that the stone is laid, the type of stone, and the way that it's laid up. Again, on page 117, you see examples of way stone might be shown in elevation. Right, here it is on this slide. And some examples of stonework used in construction. I'll have to drive around. Actually, I don't get out and drive that often, right? I work from home and I hardly ever get out of the house these days, so I'll have to find some pictures of gray stone buildings. A lot of them not too far away from me on the west side of Chicago. And again, use of stone. And also stone as a wall material. We also have structural clay tile, larger units similar to brick. Example of what clay tile looks like. Right, mortar is the material that holds the brick or the block or the stone together, right? Stone may or may not have mortar. Sometimes stone is dry laid, meaning it's laid up without mortar. So again, the wall will be composed of the masonry units, the brick or concrete block, plus the mortar. Right, mortar is going to be, I think the guy in our concrete video talked about mortar, you know, concrete, mortar, and grout as being three types of things where cement is used, right? So mortar is going to have probably a little more cement, more fine aggregates. You know, there's not large coarse aggregates in mortar. But again, we'll have different characteristics of mortar depending on the application. And some symbols, drawing symbols for masonry. Again, we will see this as we get more and more into drawings and symbols in coming weeks. Okay, let's move to division 5, which is metals. And we will show a video here. So hold on. Okay, you can see that I always have to look around carefully to find videos that are appropriate to show here, because they either seem to be things out of somebody's garage, like the first one we saw on concrete, or something like that, which is a trade organization that's trying to advertise their products. But be that as it may, let me get back to where we were here. Sorry. I'm not quite sure why they showed this little snippet of this guy arguing on the cell phone. He's probably yelling at his subs or yelling at his supplier, trying to figure out why his material hasn't arrived on the job site. Yeah, or yelling, trying to get payment out of, get paid for his work. Okay, we have basically two different categories of metals: ferrous metals and non-ferrous metals. Right, so ferrous metals contain iron. They have magnetic properties. So iron and steel are ferrous metals. We saw cast iron and wrought iron as two different types of iron. So iron and steel are ferrous metals. The other types of metals would be called non-ferrous metals. They contain no iron. They're not magnetic. So aluminum, copper, brass, or bronze would be non-ferrous metals. They had titanium in that little video. I think titanium to me is going to be something that's fairly rare in building construction, but certainly aluminum, copper all day long, right? We're going to have copper plumbing, copper in our electric wiring, aluminum in lots of places as well, right? We can treat the surface of that metal to provide either appearance, right? Used to be that cars had chromium, had chrome bumpers, right? Nowadays bumpers are made out of plastic, but years and years ago we would put a chrome plating on steel, and that would be the bumper of a car. We can galvanize steel. That's fairly common. Galvanizing is coating zinc to provide rust resistant. We also can let the surface rust. I think that's called Corten steel, C-O-R-T-E-N, right? If you're downtown, if you go to the, I think it's the Daily Center, the county court building is Corten steel. Or we can electroplate the steel. We can put a metallic coating on that steel or on that metal. Right. Gauge number is used as a measure of the thickness of sheet metal, sheet steel. And with that, I am going to stop here. My next slide will be a video, which is going to be a little bit longer than the time we have remaining. So